Hello, everyone. So welcome to Theo-MathProblem Solver. So today we are going to look at how best we can use the first, derivative to find the maximum and the minimum of minimum values of some functions. And then we'll also look at situation how best we can grab those functions. So stay with me even as we explore it together. All right. So before we dive into that, there are one or two things that I would want us to take note because you're looking at the functions. Are there situations over an interval where the function may be increasing or decreasing? So I would want us to, touch on that before we continue with our discussion. So a function, let's start that a function f, okay, is increasing over the interval, let's call it I. Then we claim that for every A and B, okay, in that particular interval, if we create a condition that A is strictly less than B, then we have that f of A is strictly less than f of B. So when this condition is met, then we have that the function is increasing. But let me just give you a picture so that you would appreciate what I just did. So suppose we have a graph as this. Suppose we have a graph as this. So this is my x-axis. So this is my x-axis, okay? And this is my y-axis. Suppose I have a function like this, okay? A function like this. So it's, let's say, start from the first point is A, we're in this domain. And the second point is let's call it the B, okay? Let's call this one the B. Now over here, we can say that if we say that A and B, they are within the interval, okay? If A and B are a member of the interval, then well, over here we can sort of, if this f is the function, let me just make it very simple so you will appreciate what I just did. So let me use a different pencil for, so if this curve is our function, is a graph of the function, okay? So we claim that such graph at this point has a value of what, f of a, right? And such a function at this point has a value of what, f of b. Remember, we made the condition that a is less than b on the horizontal axis, on the or what we call the x-axis. We said that a is less than b. Okay, and from the graph, it is obvious that a is less than b, right? So we see that this function, as a increases, as a approaches b, as a keeps approach or moving towards the right, moving towards the left of b, we see that the function continue to increase. Do you see that? So in that case, if that's the case, then we can confidently say that the f of a would also be less than the f of b. Is that okay? Is that okay? Good, good. So this is where there's a point where we say that our f is increasing. Okay, there's a point where we say our f is increasing on the interval I. All right. If at this point if you don't understand anything, please put down your question and in the comment section, and I would attend to you. All right. So let's look at the other side of the function. What if the function is decreasing? If it's decreasing, how do we approach it? So for suppose that you have a function that starts as high as this, then begins to decrease as this. So let's call this one our A and this our B. Over here, and we know that this is our F. So we know that this is our the graph of the function. And this is the value of the function at A. And this is also the value of the function at B. Now, if we say that A is less than B, if we say that let me create a condition wall so that we would kind of appreciate this. Over here, we could kind of, see something that is interesting, because this is how high the function was at point A. This is how high the function was at point A. We had a function value at this point, but we realized that the function began to decrease. Okay, up to a particular point B. Do you see that? This is how high at f of A. That was how high the function was. But then the function began to go down up to a point where B up to a point B. Okay. If that's the case, remember over the interval A was always all the time less than B. But then because the function begins to decrease, okay, it just means that our function now will operate on a different dimension. What dimension are we talking about? We will say that our f of A will be what? Greater than our f of B. So because it's obvious here, right? It is obvious from the graph that our f of A will be strictly greater than our f of B. When that happens, then we claim that our f is what? Is decreasing, or our function is decreasing on the interval, A to B. Is that okay? On the interval A to B. So our function is, or our f is decreasing on the interval A to B. Is that okay? And this is so important that we understand the basis as to at what point is a function, increasing and decreasing. So please let's take note. All right. So let's look at the first theorem for our today's discussion. So the first theorem, is so important. So please, I would want us to take note of that, because we're going to rely on that very well, and we are going to use it as a tool to solve some problems. So let's bear that in mind. All right. So let's move on. Suppose that a function f is differentiable over an open interval like a and b, okay? Over an open interval, let's say a and b. So if suppose that f is differentiable, now we understand what we mean by differentiable. In other words, it can be differentiated, okay? If it's differential, it means it can be differentiated. And you already know what it means to differentiate a function. We already know it. we've been in a previous content, we talk about how to find the derivative of a function and all of that. Okay. So if I say that f is differentiable, it means that we can find a derivative. That's what we mean. All right. Or in other words, this function can change with respect to its input. Okay. Okay. Good. So it's differentiable over an open, we say an open interval. Okay. An open interval. Let's call it I. And in our case, we are using A and B as the interval. So let's also bear that in mind. So we claim that if f prime of x, in other words, the first derivative of the function is strictly greater than 0 for all values of x in the interval, for all x in the interval, okay? Interval I. Then f is increasing, okay? We in that case, we said that f is increasing over the interval, okay? So I want us to, take note of that. And another thing is that if f prime of x is strictly less than 0 for all, for all x in the interval, I, then f is decreasing over the interval. So I want us to, take note of these theorems. Would kind of take our time to go through that, so that wouldn't be a bother for you. So I want us to also look at what we call the critical value. Now, we'll be using it a lot, so we would want to know how to find critical values of functions. Yeah, so we'll be using them. So let's take our time to know how to find critical values. Now, what is the critical value of a function? So a critical value is, we will say that it's just any number, okay, in the domain of any function for which, the tangent line is horizontal, or for which the derivative does not exist. What do I mean? So if I give you a function, okay, if I give you a function, then we claim that the critical value, if I give you a function, we claim that the critical value, let's say, so suppose C is a critical value. So if C is the critical value, if C, let me kind of write it well so that if C is critical value, if we evaluate the function at that critical value, if this exists, and then also the first derivative evaluated at C is equal to 0, or f prime evaluated at C does not exist. Okay, so it does not exist. So this is important. So let me just underline this, that does not. So let's take note of that. We'll look at more examples so that you will appreciate the definitions as well. So let me take it one more time, that if C is a critical value, if the function being evaluated at C exists, okay? and that the first derivative also evaluated at C is 0. Remember I mentioned that the tangent line evaluated at the critical point should be horizontal. Now that's why this is 0, because this is horizontal, right? Or or the first derivative being evaluated at critical point does not exist. So these two definitions are very, 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 important. And that, so this is so important. I want to take note, and that the fact that, this definition is concerned. Okay. So the function, or the first derivative evaluated at C does not exist. It's also so important, especially when you find some in rational functions. If you want to find a critical value, sometimes this definition that I've put square around it is also important. So I want us to please take note. All right. I would also want you to take note that I want you to take note that this is what we call the critical point. Okay. So we call this one the critical point. Okay. So the critical value, if when you combine the critical value in it, and then the function being evaluated, see that becomes a critical point. Okay. So I want us to please take note of that. It's so important. All right. So at this point, I would want us to kind of look at the table. So this table, because I want us to be talking about relative minimum and then relative maximum. So I'm going to use this table to explain certain basic terminologies, and how best we can leverage those terminologies to solve problems. Okay, so please let's take our time to understand this particular you know uh, table. So when we look at the first graph, I mean this one. When we look at the first graph, we see that this graph is kind of given within an interval. Okay, so the graph of this function is within an interval, which is a and b, right? It's a and b, and in between them we have c, and the c at this point is what we are referring to as our critical value. Our c is what we term it as the critical value. Now we over here, this is what we are going to do. We see that this particular, so before I kind of delve into that, I want us to please take note of something. All right. So over here we see, let's look at the sign of f prime of x for x in the interval AC. So when we look at the interval AC, look at the horizontal axis over here, the interval AC over here. Let me just use different pencil. So we are looking at this side, okay? So you're looking at the interval AC. The interval AC, we see that the graph of the function was decreasing at this point. Do you see that? Now at point A, this was how high it was. But then it begins to decrease towards C. So within this interval, we see that the function was decreasing. So what it means is that f prime of x being evaluated at that interval is negative, and that is why we have the negative here. Is that okay? Now, let's look at the other side. We see that within the interval CB, we saw that the function now at began to sort of increase. So from this point began to jump onto this point. So there's an increase at that point. So at that point we claim that the slope within this interval was positive. We know that it was going up, or right, or it was increasing, and that's why we have the positive, sign here. Is that okay? Good. Now, at point A, at point AC, what can we say? At point AC, we claim that the function was what? Decreasing. So the function was decreasing on AC. On AC, we saw that the function was decreasing. Okay. And then also at point CB, we saw that the function began to what? To increase. And that is why we have this as well. So all of these things, I'm saying of this so that you would kind of appreciate them when you begin to sort of, solve problems. So I want you to take your time to make sure you understand this. You have, depth insight into these things so that you would know how to use them when problems come, or when I give you some stuff to try on your own. So I want you to please take your time to make sure you really, really understand what we are doing. All right. Now, a situation where the graph of the function is of this nature. It's of this nature where, it's almost as if the graph is open upwards. Then it means that you're going to have minimum, right? It means that that graph is going to have a minimum, right? So in our case, we are going to say that such a graph would experience what we call, or will have what we call the relative minimum. Is that okay? So you're going to have relative minimum. Now, on the contrary, there's a graph that opens downwards. Okay. So we saw that this graph is opening downwards. But what can we say? It's opening downwards, all right. It's also opening down within the interval AB, right? Very good. And over here we can see that from at at within the interval A to C, we saw that the function begins to increase, right? It started increasing from point A until a certain point beyond A, right? Good. Then we saw that within the interval, then we also saw that within the interval CB, we saw that the function or the graph of the function began to decrease. So what can we draw from this graph? We kind of see that the f prime of x, or the f prime of x, is also known as the slope, or the slope within the interval, the slope within the interval, within the interval AC was increasing, and that's why we have this positive sign, right? Good. And we also see that the slope of the function within the interval CB was decreasing, and that is why we have this minus. And we also mentioned that the graph of the function was increasing within the interval AC, and also begins to decrease within the interval CB. So all of these things, I want to make sure that we kind of understand it so that we can, solve problems. Is that okay? All right. At this point, if you have not subscribed, please do so. Like my content, share the content with other colleagues, turn on your notification button so that anytime I release new content, you'll be the first to receive it. So I also want us to look at a different table where it kind of give us a different perspective on how best we can, solve problems or approach problems. Now, let's go at the first graph. The first graph is this one. So let us to focus on that. We kind of see that within the interval, remember the graph of these functions within the interval AB, right? But within the interval AC, we saw that the graph began to decrease, right? So the slope began to go down or the decrease. And so let me use a different pencil instead of using that. So within the interval AC, we saw that the graph begins to go down. And then also from within the interval within the interval C, B, we saw that the graph also begins, or the graph of the function begins to decrease as well. So in that case, what can we say? That's decreasing throughout, right? So in that case, we're not going to have uh, neither relative maximum nor minima, right? So I think this is something that I would want us to take note. There's a decreasing throughout. So in that case, we would only have the sign of the slope to be only negative. On the other side, or the other what's the name? The other graph of the function, we saw that it's just the opposite of the first one, right? So we also saw that was positive throughout and increasing throughout. And since there is that, just means that there will never be, relative maxima or minima. So please, I will want us to kind of take our time to kind of have greater insight on all of this. So I will want us to solve this particular problem and see how best we can leverage on what we have studied so far. Now, this question says that we should grab the function f given by this particular function, and we should find a relative extrema. So when you say relative extrema, what comes to mind? So extrema, so the word extrema, relates to minimum and maximum. So please, let's take note. And then when I say extrema, I mean to say minimum and then the maximum. I want you to take note of that. So let's go to how best we can solve this particular problem. All right. So we are given this function. They're given this function to solve. So we have f of x equal to 2x to the power 3 minus 3x squared minus 12x plus 12. All right. So the first thing to do, so for now, I would not want us to graph it right away, but I want us to find the relative maxima, our extrema, and based on that, we can use that to graph, right? That one is easy. All right. Now, the first thing to do is since we are looking at the extrema, the first thing that comes to mind is important that we find the critical values, okay, of the function. So we have to find the critical values. Now, how do you find the critical values? So the first thing to do, if you want to find the critical values, first, you have to find the first derivative of the given function, right? So the first derivative of the given function will be what? So our f prime of x should be equal to what? That should be what? 6x to the power 2 minus what? 6x minus 12, right? Now, to find the critical value, so since this is just a polynomial, we are going to stick to the case where we're going to set just this to 0, okay? Since this is just a polynomial. Okay, so you're going to make sure that we would kind of solve for this. And I also mentioned that there's no, for polynomial function, there's no value where the first derivative would not exist. So I want us to take note. So the only possibility will be this one. Okay. So what you're going to do, you're going to set this to 0, then we solve. Is that okay? Good. So in that case, so this implies that our 6x squared minus 6x minus 12 should be equal to 0, right? So what we can do is to kind of divide both sides by 6, right? So we can divide both sides by 6, and that gives us what? X squared minus what? X minus what? 2 equal to 0. And that when you expand and simplify, you should be able to get something as plus 1 equal to 0. So we're going to have -1 or x equal to 2. So these are our critical values, okay? So our critical values, we have -1 and 2. Now, there's something that we need to do. So what we are going to do is that, remember, we kind of talk about the interval on which the function began to increase, decrease, and all of that. But remember that C was what we're using over here in the table. In the table, we're using C. Remember, C was what was kind of split in them. So the C was the critical value. So we're going to look at a situation where to the left and to the right of the critical point, we want to see what is going to happen. Okay. So we are we also want to observe what is happening. What is the function going to increase? Will the slope be increasing or be decreasing? So this is something that I would kind of want us to kind of take note. So I want us to test. Okay, so let's do something here. Let's do something interesting. So let's assume this is a number line. We have our -1 here, and then so let's say this is our -1, and there is -2, and these are critical values, right? So we want to kind of pick some values within this interval. So let's say from -1 to negative, no, let me change it. Oh, this shouldn't be that. So it should be -infinity to -1. Within -1 and -2, we'll pick a value, okay? And then from 2 to 3, we'll pick some values just to see how best it will help us, right? We'll also be picking, let me use, let's see, -1 and -2. And within this range, from 2 to positive infinity, what values are we going to use? So in that case, let's try and maybe build a table that would help us. Okay. I think that table would be easy to use. So let's look at some test value. Also look at the sign of f prime of x. Okay. And then maybe the result, how we can conclude on the result. So within the interval -infinity and -1, what value do you want us to use? So once say, maybe we can pick -2 from that range, okay? Within this range, I want us to pick -2. And within this range, from -1 to -2, what value do you want us to pick? Okay, we can just pick 0, okay? Now, from 2 to positive infinity, what value do you want us to pick? So we can pick, let's say, 4, right? All right. So this is our table, our simple table. Now, what we're going to do is that we are going to plug these values into the f prime of x. Remember f prime of x. Remember that our f prime of x was given as what? Was 6x squared minus 6x minus 12. So you're going to plug these values into the f prime of x. Okay. F prime of x is the slope or the first derivative. So you're going to plug it into that. What do we get? So when you plug -2 into f prime of x, so we are going to, at this over here, we're going to have positive, and when you plug 0 into f prime of x, we're going to have what? -12, which is what? Negative. And when you plug in um, uh, 4 into the slope, you're going to have positive, right? So please take note. So what can we say about the result? So the conclusion over here is that because at this point f is increasing, because f the slope was plus, we will say that f is what? Is increasing on what? On where? On this range, which is negative infinity to -1, was increasing. That was what because the value we picked was -2. And at that point, we saw that it was positive. That's why we say it is increasing. And over here, we saw that it's negative. So it means that our f is what? Is decreasing on what? -1 to 2. And over here, we saw that f was what? What is positive? We said that f was what? Increasing on 2 to positive infinity. Is that okay? Good, good. So now that we know this, so it's kind of interest for us to know what is happening, right? Now, over here at this point, looking at this table, it is easier to draw the graph, right? Now we know where it is increasing, it is decreasing. So it is easy to kind of draw the graph. Now, by looking at the sign of f prime of x, it is easy to know that. Now, because we saw that f prime of x is increasing. So if it is increasing, it just means that it's going up like this. Then it goes up, it is increasing, then it begins to fall, then it is increased again. So at this point, it's easy that the graph of a function will be this because it begins to increase, goes down, then it increases again. So I would so over here, it is easy to know that this is the way the function or the graph of the function would look like, right? But then remember, the question was more specific that we should come on, we should find the relative extrema. And I said extrema is just mean minima and maxima. So please, let's take note of that. Over here, we can see that the function, the graph of the function attains its maximum over here and its minimum over here, right? But what critical value was causing this or was helping us to get this? And the easiest way for us to do is that, so over here we saw that at -1, we kind of saw that there was an increase at within the interval or at the critical value -1. We saw that the function was going up, then it came down. So it went up because there's a plus over there. Remember, at that point or around that point, we saw that around the critical point, which is -1, we saw that the function went up, then it came down. So it went up and came down, which indicates what? A maximum somewhere. Remember, it went up and it came down, right? So it went up over here, then it came down, which shows that there was a critical point somewhere here. Okay. And then the other one, we saw that the function went down and it went down and then went up again. So which indicate relative minimum at that point. Okay. So I want us to take note of that. So we say that f has a relative maximum, at x equal to 1, which is given by now what you're going to plug that value into the main function. Remember our main function, let me kind of go to our main function. Our main function was, I think, s cubed minus 3x squared minus 12x plus 12, right? I think that's what it was. So when you plug in, you should have something as this, which should give us 19. Okay, so that's, we will have that -1 and 19 as a relative maximum. Is that okay? Good. And but then remember, we kind of have another critical point. We also saw that f has also that s has a relative minimum at x equal to 2. Why did we say so? Because we saw that around the critical point 2, we saw that the graph of the function went down, then went up. So it first came down, then it went up again, which shows there should be a minimum somewhere at the bottom. Is that okay? Good. So given by, so we evaluate it at the main function, and that should give us something as this. So in that case, we kind of conclude that to a negative, this is a relative minimum. Is that okay? Good, good, good. So at this point, if you have any questions, just let me know, and I will take my time to kind of explain it. If you have any any concern, please put it in the comment section, and I would kind of attend to you. All right. So been able to tackle the first problem of the day. Let's get the second problem of the day and see how best we can also leverage the theorem that we discussed earlier. Now, in this problem, we're asked, so this is problem 2. So in this problem, we're asked to find the relative extrema for the function given by this, and we are to kind of sketch the graph of the function. Okay. Now, the first thing to do, now we know what to do. So the first thing to do is to find the critical value. Now we need to find the critical value. Now to find the critical value, it is imperative that we first find the first derivative, right? So let's find the first derivative of the given function. And that should give us what? That should give us what? That should be 2 out of 3 multiplying x minus 2 to the power of -1 out of 3. Yeah, that's what we're going to have. So to find the derivative of this function, in the previous videos, we kind of talk about this. So I jumped over here. All right. Now, let's try and rewrite this function. And that should give us what? 2 out of 3. Then the cube root of what? X minus 2. All right. Now, let me add this question. What would be the critical point of this? Remember that to find a critical value of a function, we kind of said that the f f prime being evaluated at that point should be 0, or the f prime of x should not exist, or f prime of does not exist, right? But remember that this function, remember that this particular result can never be 0. It can never be 0. So it means that we have to rely on the other side, which says that f prime of x being evaluated as f prime being evaluated as c must not exist or does not exist. So at what point would this or would this rational function cease to exist? At what point? Remember that if x is 2 over here, if you replace x by 2, you remember that this function will blow up, right? It's like you're dividing 2 by 0, and that it will be indeterminate or undefined. So the function will cease to exist as 2. So in that case, our critical value would then be 2. As the name implies, when something is critical, it means that's a point of crisis, right? There'll be a crisis at the point 2, because if x is 2, we see that you're going to have 2 over 0, and that is a point of crisis. We don't want that. The function will blow up. We don't want that, right? So that is the point where we're going to have a critical value, okay? So in that case, we're going to have our critical value. So the critical value will be x equal to 2. So this is going to be our critical value. Is that okay? Good, 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 good. So if you have any questions, please put it in the comment section, and I would kind of attend to you. So since this is just the critical value, it is important that we kind of look at around this critical value, what is happening around it, okay? And that's what we did earlier on. We're kind of trying to figure out what is happening around this critical value. So it is just 2. So you're going to look at what is happening around this critical value. So let's look at the situation from negative infinity up to 2. Let's see what is going to happen. And also from this point, so it's from 2 to positive infinity. What is going to happen within around that interval? So let's go. So with that, what usually I think I tell my student to do is to use a table. It is the table makes life easy. Okay, the table is easier to help you to rather demystify demystify the problem and try to break it down into easier to solve. Okay, so let's take note of that. So with the table, as we did earlier on, the table, we start with some test value. Let me use different pens. So we kind of use some test values. Then the sign of f prime of x, and then the result. Okay, good. So from negative infinity to 2, what value can we pick? Let's say 0. And then from 2 to infinity, what value do you want us to pick? Okay, let's pick 3. Okay, then we plug it into the f prime of x. So this is our table. Now, when I remember, our f of x is here. Now, when x is 0, remember within the interval negative infinity to 2, we pick a value to 0. Now let's plug into into f prime of x. When x is 0, what do we get? We're going to have minus, right? So we'll have minus here. And then when x is 3, what do we get? So we are going to have what? Positive, right? So you're going to have positive. So you're going to have that. So in that case, what can we say over here? Over here, we say that f is what? Is decreasing. S is decreasing on the interval negative infinity to positive infinity. And over here, we kind of say that what? our f is what? It's increasing on positive 2 to positive infinity. Is that okay? So it's important that we kind of know how to do this. Now over here, it is easy to now to kind of give the graph of the function, right? Because you are starting from decreasing to increasing. From decreasing to increasing, what comes to mind? So from decreasing to increasing, visually, what comes to mind is what? From a lower to higher, so it means would eventually be looking at or be talking about the relative what minimum. From lower to higher will be relative minimum. From higher to lower would be kind of looking at relative maximum. So please let's take note of that. Now, over here we kind of have an idea that our f has a relative minimum origin has a relative minimum at x equal to 2, okay, which is given by, now these two we're going to plug into the main function, and you're going to have what? 2 minus 2 to the power that plus 1, and that should give us what? 1. So this implies that our 2, 1 is a what? It's a relative minimum. Very good. Good student. All right. So please, I would want us to kind of, take note of that. So since it's a relative minimum, it just means that if I want to give a sketch of the graph, it just means that, remember there was a decrease. So it just means the function was going down. Remember the sign of the slope. It was, see if it was going down as this, then at some point, remember you had then it begins to go up. So this is the way our function would, or the graph of the function would look like. So let's take note of that. It came down because it was decreasing. It came down and went up. So that's where we are going to have, we are having our relative kind of minimum. Okay. Very, very good. Very good. Very good. So let's look at another last example. Then we'll say goodbye to this. Then we'll kind of look at other interesting stuff. Okay, good. Now, example 3, I would want us to kind of find the relative extrema of the function h given by this. So with this one, I would not do everything, but what I would do is that I can give you a sketch of the solution. Okay, I can give you a sketch of the solution. So first we're gonna find the h prime of x, and that should give us what? What should be h prime of x? That should give us what? 4x cubed minus what? 8s squared. Now, remember to find the critical value, we said that our f prime of x, remember this one is just a polynomial, just equate to 0. Then you would kind of continue with the discussion. So at this point, if you have not subscribed, please do so, and so that we can, kind of help, help others who are kind of, struggling in mathematics. I also want to kind of point out that if you kind of have any issue, have any trouble, just reach out to me by by could be my email or anything. Or you can also put it in the comment section, and I would kind of attend to you. At this point, I want us to look at the last problem of the day. With this problem, at the problem I just put, I want you to do it on your own. But this last problem, I want us to kind of look at it because I love it so much, and it's something that I usually like to give to my students. And so let's try and see. So it says that find any relative extrema and sketch the graph of the function. Okay. Given by all right. So how do you solve this problem? How do we solve this problem? Now, the first thing to do is to find a critical point. Now, how do you find a critical point? The first thing to do is to find the derivative. So our g prime of x should be what? Remember, this is a product of two functions, right? So we kind of do cover up to do the differentiation. So we can first cover the x squared and then differentiate the e to the power minus x, then plus, then we kind of cover the f of x and then differentiate our x to the power 2, right? We just use the product rule. Now, when you differentiate e to the power minus x, that gives us what? Minus x squared e to the power minus x. And then when you differentiate x squared, what do you get? You get 2x, then we multiply it by the what is outside. So we have something as this, right? So at this point, what we'll do is that we are going to find a critical point, and by finding a critical point, over here, let's try and gather the, let's try and factorize, okay? By factorizing, we should have something as maybe 2 minus x. All right. All right. So we have this. Now we need to find where g prime of x is 0 or g prime of x does not exist, right? Because these are some of the definitions of a critical value. And we kind of mentioned it, I've mentioned a couple of times. So this way we can also, try and see whether we really understood what we talk about. So it means that our x multiplying e to the power x 2 minus that should be equal to 0, okay? For critical values. For critical value. So we kind of set this to 0, okay? Remember that, I want you to remember that e to the power minus x can never be 0. E to the special exponential function can never be 0, okay? I want you to know that it can never be 0. So in that case, the only value we can have is, what? 2 minus x being equal to 0. In that case, my x should be what? Should be 2. Is that okay? So I want us to kind of take note of this. And then also, we also have another one, which is x also equal to what? 0. Okay. So now it means that x, it just means that our critical values, the critical values will be 0. Let me use, will be 0 and 2. Okay. So we use these values to also, construct our table as we did before. So we're going to have our table. So our table, we're given So let's look at the interval. So the interval, so let's draw a line. So we have 0 here, and then we have 2. So we're going to have the interval from negative infinity to 0, from 0 to 2, from 2 to positive infinity, okay? And then let's, draw a table as before. So we're going to draw a table as before. So our table, we kind of look at the test value, okay? You're going to have the sign of, g prime of x, and then what? And then the result. Now, within the interval negative infinity to 0, what value do you want us to pick? So we can pick -1, right? And from 0 to 2, what value do you want us to pick? Maybe we can pick one from the 2 to infinity. We can pick maybe 3, right? Let's pick that and see how best we can solve this problem. All right. Now let's plug these values into the g prime of x. Remember the g prime of x, this is our g prime of x, right? This is our g prime of x. So that's what we're going to use. So we plug it into it. We have g prime of x to be x multiplying this 2 minus x, okay? So for the first one, when x was -1, let's try. When x was -1, what do we get? So we are going to have what? It was what? Negative, okay? The sign was negative. And when we plug in y into that, you're going to have positive, and this one was what? Negative. So what can we say over here? If that's the case, it just means that my g is increasing, right? It just means that my g is, sorry, it's decreasing over here because it's negative. It's negative. So let me just take my time and write it. So just since it's negative, it just means that since the slope is negative, it just means that the graph of the function was decreasing at this point, was decreasing here. And over here, we said that g is what? Increasing. Good, good, good. And over here, we see that g is what? Decreasing. Good, 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 good. Good, 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 good. Now that we know that, so we over here, we can confidently see something that is interesting as far as the graph of the function was kind of concerned. We see that over here it is decreasing, then it increased and comes down. So it's almost as if almost as if the graph of the function will behave like this. Will behave something like, because there's a decreasing here. Okay, so first it decrease, it as if it's like this. It decrease, then it goes up, then it falls. So it's as if the graph of the function will behave like that, okay? It's almost as if it will behave like this. This is just a sketch of just a sketch of the solution. So take note. Now, when that happens, what can we say? Remember, we kind of have to evaluate g of x at the critical value. So at remember the critical values were 0 and 1, right? And 2, sorry. So we plug those values into the main function, and that should give us what? 0 squared e to the power -0. And that should give us 0 point. And that is 0, right? So it just means, so does over here does 0, 0 is a what? It's a relative what? Minimum point, okay? And then G evaluated at 2 equal to what? 2 to e to the power 2. And that should give us 4e to the power 2. So it's a relative maximum point. Okay. So at this point, I believe that with these examples, I believe that it should be okay anytime I give you questions and I ask you to find a relative extrema. I think you will not find yourself wanting. You just have to leverage such principles, tools, concepts, theorems, and you should be able to solve any question at all. All right, at this point, if you have not subscribed, please do so. Share the content to your colleagues, to your loved ones, and let's keep spreading, the good news. Thank you so much for your time, and stay blessed. Bye.